for the information we have, the second term of the arithmetic sequence is 10 and the fourth term is 22. So knowing that information, let's start on A. So A, we know that the second term equals the first term plus D, and that is equal to 10. Then we know that the fourth term is equal to the first term plus 3 common differences, and that equals to 22. And so if you were to take U2 and you do U1 plus D equals 10 and you minus that from the fourth term, you will get that 2D equals 12, and so D, or the common difference, equals 6. Then moving on to part B. So going back to the second term, we know that 10 equals the first term plus 6, so the first term equals to 4. Then putting that into the arithmetic sequence formula, we would get that UN equals to the first term, which is 4, or U1, plus the term number minus 1 times the common difference. Question 2. So we know that Claire rolled a die 16 times, and these are the scores, and then these are the frequencies. And so, knowing that, we can move on to A. So for A, we know that P plus Q equals to 16 minus 4 minus 2 minus 0 minus 3. This is because these are the frequencies, and in total, these should add up to 16 because the person rolled the die 16 times. And so over here, we could get that P plus Q equals 16 minus 9, and that is equal to 7. And so we could find another equation using the mean score. And for this, we would do 1 times P plus 2Q plus 3 times 4 plus 4 times 2 plus 5 times 0 plus 6 times 3 over 16. And then that would give the mean score, which is 3. And so after simplifying, we will get that P plus 2Q plus 12 plus 8 plus 18 equals 48. And so P plus 2Q equals 48 minus 38. And so P plus 2Q equals 10. And then we could take the previous equation, P plus Q equals 7, and that would give Q equals 3. And then we solve it back to the previous equation, which is P plus Q equals 7, and so P plus 3 equals 7, and so P equals 4. And then we would find the final mean score for B, and then that would simply be 3 times 10, and that would be equal to 30. This is because the mean score is 3, and then that would be equal to what we were given over here, and so we could just times the mean by 10. Question 3a, we know that log 10 to 1 over a is equal to log 10 to a to the power of negative 1. In power rule, this equates to negative log 10 of a. And so we know what log base 10 of a is, and so we just substitute it, and we could get that the value of the equation in A equates to -1/3. Moving on to B. So for B, we will have to use the change of base rule, where log base 1000 of A equals to log A over log 1000. And so that would be equal to log A over log 10 to the exponent of 3. And again, using the power rule, we would get that log A equals to 3 log 10. And so we could do that this equals 1/3 times log base 10 of A. And so this would be equal to 1/3 times 1/3, and then we will get 1/9. So for question 4, we know that the perimeter is 10 centimeters. And so for question A, we know that 2R, which is these areas, plus the length of the arc, which we know is r theta, equals to 10. And so, therefore, r equals 10 over 2 plus theta, and also that theta is equal to 10 minus 2r over r. And so then we would use the other formula, this formula, in which the area 6.25 is equal to 1/2 r squared theta. And so through this, we know that r squared theta is equal to 12.5, and thus theta equals 12.5 over r squared. Then we would go back to this formula, in which 2r plus r times theta, which is 12.5 over r squared, equals to 10. And so 2r plus 12.5 over r equals 10. And so we get 2r squared plus 12.5 minus 10r equals to 0. And then you multiply this whole equation by 2, we will get 4r squared minus 20r plus 25 equals 0. So thus, we could prove that according to what we are given, 4r squared minus 20r plus 25 equals to 0. Moving on to B. Given that 4r squared minus 20r plus 25 equals 0, this is a perfect square, and so that equals to 2r minus 5 squared equals 0. So we get 2r minus 5 equals 0 and 2r equals 5. And so r equals 5 over 2. And this is because r, which is a length, cannot be negative 5 over 2. So thus r could only be 5 over 2. Then we go back to the previous formula. 2r plus r theta equals 10. So then we sub in the value of r. So that would be equal to 2 times 5 over 2 plus theta times 5 over 2 equals to 10. And so we would cancel this out. And so theta equals 2. Question 5. So for part A, we know that point C is an intersection of the two functions, and thus we could equate that cos x is equal to sine 2x. So 0 equals sine 2x minus cos x, and sine 2x is equal to 2 sine x cos x minus cos x. And so after simplifying, we will get that this is equal to cos x times 2 sine x minus 1. And so through this, we could derive two roots, where cos x equals 0, and thus x equals pi over 2 and pi. Then for the 2 sine x minus 1, we know that sine x equals 1 over 2. So that means that the RAA is equal to pi over 6, as according to the special triangle, in which 1 root 3, 2, where this angle is pi over 3, and this angle is pi over 6. Then, according to our cast, sine is positive here and here. So knowing that these angles are pi over 6, we know that x equals to pi over 6 and x equals pi minus pi over 6, which is equal to 5 pi over 6. And then going back to the question, we know that x equals pi over 6 for point A, and then x equals 5 pi over 6 for point C. Question 6. So for question 6a, we would use the formula booklet U1, which is 1 times the common ratio, which is 10 to the exponent of n minus 1 over 10 minus 1. And that is equal to 10n minus 1 over 9. Moving on to b. If you look at these, S1 will be 10 minus 1 over 9. S2 will be equal to 10 squared minus 1 over 9. And S3 equals 10 3 minus 1 over 9. So as you can see, the denominator does not really matter because it's a common denominator. So we do want to focus on the numerator instead. And so if we look at the pattern, we could actually use the sum of finite geometric sequences and approach this. And so looking at the top, it is 10n minus 1. And so we could use, again, this formula where this would be simply equal to 10 plus 10 squared plus 10 cubed. And so that would be equal to 10 times 10n minus 1 over 10 minus 1, and that would be equal to 10 times 10n minus 1 over 9. And then we could look, so this is the explanation for the 10 to the exponent of n, and then for the negative 1, if we were to continue with the terms, it would just be negative 1, negative 1, negative 1, negative 1. And so we could say that that is actually just negative n. Because at S2, in total, it would be negative 2. At S3, in total, it would be negative 3. And so after breaking this down, we could see that essentially the overall formula for a finite number of this geometric sequence is 10 times 10n minus 1 over 9 minus n over 9, and that would yield 10 times 10 to the n minus 1 minus 9n over 81, and thus we prove this equation. Question 7. So for part A, we're simply finding the derivative. And so for the first one, dy over dx is equal to 3x squared minus 2x minus 1. And this is because y is equal to x cubed minus x squared minus x plus 1. And so we know that taking the derivative means that you're moving the exponent to the front of the term, so it turns into a coefficient, and then this number over here would minus 1. And so thus that would be what we have here, which is we carry over the 3x, and then 3 minus 1 is an exponent of 2, and then you would do minus 2, and then simply x, because 2 minus 1 is the exponent of 1. And then for this third term, for x, it simply turns into 1 because x to the 0 is also 1. And then this will just turn into 0 because it does not have a coefficient. And then for the second one, d2y over dx squared. We would repeat the process again, where we get 6x minus 2. So moving on to b. So for b, we have 0 equals 3x squared minus 2x minus 1. This is because at a local maximum or local minimum, the slope is equal to 0. This can be seen where it is just a flat line, and so thus the slope is just 0. We would simplify this function to get 3x plus 1 and x minus 1. So that would mean that the roots are x equals negative 1 over 3 and x equals 1. Then you would use part 2 of a, where d squared y over dx squared is equal to 6x minus 2. So 0 equals 6x minus 2. So x equals 1 over 3. Then you would want to draw a chart with your factors, 6x minus 2, and then you would add all of your factors that you have, all of the zeros that you have found, and then you would label it on here. And so this is a second derivative test where you would mark the 0 at the 0 that you found for the second derivative, and then on the left it will be negative, and then on the right it will be positive. And so this will be concave down, and this will be concave up. And so thus the local max is at negative 1 over 3, which means that in the graph, negative 1 over 3 is the local max. And this is because it is the point of a concave down curve. So in comparison, if it were to ask for the local minimum, then it would be 1. So this means that in the actual graph, the graph would look like this. And then after finding the local max, we would sub the x value back into the function or equation to find y. So y equals negative 1 over 3 cubed minus negative 1 over 3 squared plus 1 over 3 plus 1. And so that would be 1 over 27 minus 1 over 9 plus 1 over 3 plus 1. And so we get 1 minus 3 plus 9 plus 27 over 27. And that would be equal to 32 over 27. So thus the coordinates of A are negative 1 over 3, which is x, and 32 over 27, which is y. Now moving on to C. So the point of inflection is always at when the second derivative is equal to 0. So that is dxy over dx squared equals to 0. And this is always where the inflection point is at. Y prime prime, or y to the second derivative, is negative 1 over 3, 1 over 3, and 1, in which it is concave down and concave up. And so, thus for y, it shows that it is this shape, in which is negative 1 over 3, 1 over 3, and 1. So therefore, 1 over 3 is the x-coordinate of point B. For part D, you would have to find the tangent first. And so the tangent of the curve is equal to the first derivative's value at the point. And so this means that at x equals 0, y prime, which is 3x squared minus 2x minus 1, where you sub in x equals 0, y prime equals negative 1, which means that the slope at x equals 0 of the curve is equal to negative 1. And this means that this is the tangent, and so the normal to the curve would have a slope of a negative reciprocal of negative 1. So thus, the perpendicular slope is equal to 1. And then sub into y equals mx plus b, you get y equals x plus b. And since we are given a point over here, we could easily sub in 1 equals 0 plus b, and so b equals 1. And thus, the equation of L is y equals x plus 1. And do pay attention that if you say L equals x plus 1, you will be marked wrong. Question 8. The vertical asymptote would simply be at x equals 2. And this is because you cannot have a function or anything with a real possible number when you have a denominator of 0. Then for the horizontal asymptote, would be at y equals 4. And this is because when the degree of the numerator and the denominator are the same, the horizontal asymptote's value would simply be the coefficient of the numerator over the coefficient of the denominator. And so 4 over 1 is equal to 4. And then for the x-intercept, the numerator will be set to 0, and this is because if the numerator is 0, then no matter what the denominator is, it will be equal to 0. So in this case, we would set the numerator to 0, so 0 equals 4x plus 2, and thus x equals negative 1 over 2, and so this means that the x-intercept is negative 1 over 2 and 0. Moving on to the y-intercept. We would set the x value to 0, or 4 times 0 plus 2 over 0 minus 2 means that y equals negative 1, so that would be equal to 0 and negative 1. We would simply have the range, which is a restriction of y, and that is y such that y cannot be equal to 4 and y could be any real number. Moving on to C. The axis of symmetry is the mean of the two roots. -1/2 plus p over 2 is equal to 2, which is the axis of symmetry. And so we could get that -1/2 plus p equals 4, so p is equal to 9/2. For D, we would take the roots and then we would reverse simplify. So if x equals 1/2, -1/2 for one of the roots, then that means that that's 2x equals -1, and 2x plus 1 equals 0. And then x equals 9/2, which is p, and so 2x equals 9, and 2x minus 9 equals 0. So through this, you would find the two factors of g of x, and so you would do g of x equals 2x plus 1 times 2x minus 9, and then you just multiply and get 4x squared minus 18x plus 2x minus 9 is equal to 4x squared minus 16x minus 9, and so you get 4x squared minus 4x minus 9/4. And b equals -4, and c equals -9/4. Moving on to E. So the vertex is at the axis of symmetry, and so that means that we find what y is when x equals to 2. And so, of course, we just sub it into the function where g of 2 is equal to 2 squared minus 4 times 2 minus 9/4, and that is equal to 4 minus 8 minus 9/4. And then that is equal to -4 minus 9/4, and so -16 minus 9/4, which is equal to -25/4. Therefore, the y coordinate for the number of solutions, we could simply draw a sketch of the two functions together. Question 9, part A. So for question 9, part A, after she draws a blue button, she'll add another blue button. And so Q would be equal to 2 blue buttons out of 5 blue buttons. And then the rest would be red buttons, which would be 3 out of 5 probability. Then for the probability of the same color would be equal to getting to reds plus getting to blues. And so that would be equal to 7 out of 10. And then for part C, we'll do probability of 2 red, given that they are the same colors. And this could be seen through conditional probability. And then subbing in the values, we would get 3/5 divided by 7/10, and that would simplify to 6/7. Moving on to D, we know that B is equal to 3/5. And so A is equal to 1 minus 3/5 minus 1/10. And A equals 3/10. Then for E, the expected number of red buttons is 0 times 1/10 plus 1 times 3/10 plus 2 times 3/5, and that is equal to 3/10 plus 12/10, which is equal to 15/10, which is equal to 3/2. Then for the third button to be blue, the probability is 1/6. And so this could be seen through the previous graph given, where red, blue, 3/4, where after drawing a blue, and this could be seen through this visualization, where after drawing a red a second time, the probability of drawing another red for the third time is 5/6, because the person adds another red button after drawing. And so if the total probability is 1, then 1 minus 5/6 is equal to 1/6, which is the answer. And so the probability of third is blue is equal to 1/6. Moving on to G. So for G, we would need to find the number of red selected first. And so if we were to look at the pattern, in the first selection it would be 3/4 for red, and then 4/5 for red, and then 5/6. And so we could see a trend where these numbers simply cancel out because they're numerators and then they're denominators. And so over here, n equals 1, n equals 2, n equals 3. And then on the next try, it will be 1 out of 7, for instance. So in this case, n equals 4. So we could see a trend in which the probability of the selection of reds in general is 3 over n plus 2. Because we could see that the probability of the blue marble is n plus 1 over n plus 2, but since it gets canceled out, we get the denominator of n plus 2. And then the probability of the next one being next being blue is equal to 1 over n plus 3. And this could be again seen through this example where 7 equals 4 plus 3. And then we would multiply these two probabilities of n minus 1 reds, then a blue, equals 3 over n plus 2 times 1 over n plus 3. And so that would be equal to 3 over 56, and then three over n plus 2 times 1 over n plus 3. These would cancel out, and so we could see that n equals 5, because 56 is equal to 7 times 8.